Hello, physics students. I'm going to give you a little bit of instructions about how to complete the day 2 part of the dry ice puck slide down a ramp. To do that, I got to go through and just get a little bit of data, which I will do quickly. So if you had any trouble with the first day, then this part here at the beginning of the video should be helpful for you. So let's see, I'm going to got my video set up. I picked a dry ice puck and a ramp angle. Pretty happy about that. And then I can find that frame, maybe right there is where the little ribbon gets cut. So that's where I want to start my timer. I'd like it to be 0 right there. I'm going to move that over here. Get my ruler, and let's see, how is the way to rotate this thing? I think I have to grab that little dot at the end of it. I can rotate it, try to get it lined up with the ramp. That looks pretty good, and I'll have the edge of the puck be right there at 0. All right, that looks good. I'm going to go ahead and I got a little Google Sheet going here, and I made columns time, position, and then eventually I'll show you how to make the velocity column here. That's what the main point of this video is. So for the times, let me go back here and see what I think I want to do. I'm definitely going to start at 0. So go ahead and pop that in there. 0, and then how many frames do I want to do? Let's see, what is that? How about every, it's barely moving there. So maybe I'll do every 10th of a second. See how that goes. Okay, so at 0.1 seconds, it looks like it's at 2 centimeters. 0.1, 0.2. Let's see if Google Sheets, these programs, you know, these spreadsheet things, sometimes they can figure out what we want to do. And you can do that little like drag thing and it'll figure out, oh, this guy wants to go up by tenths. It didn't work there, so I'm just going to type them in manually. But it will work here when we do this velocity thing. I'll show you how to do that. So I'm going to get, we're going to need more data points than this. Maybe I'll just go for these 5. So this is at position 0, and then at time 0.1. I put my units to be meters because I'm a big fan of SI units, so that'd be 0.02. Centimeters is 2 centimeters is 0.02 meters. Okay, so I'm going to go back to my video, get another point. I'm going to click this up to 0.2 of a second. Oops, shot right past it. There we go. And it looks like it's at 8 centimeters now. This is not a suggestion that you need to use this dry ice puck in this angle. This is just the one that I picked. So you can use whatever one you had from day 1, 0.08. All right, let's see what we got next. Click up to 0.3. And looks like that's at 0.18, 18 centimeters. 0.18. And last one that I'm going to get here, click up to, I'm looking right here to make sure I'm clicking up the right amount of time. That looks like 32 centimeters. So I will do 0.32 right there. Okay, cool. Now I can go ahead and put that into graphical analysis. You can also use Logger Pro if you want. Oh, I don't think any of this is too time consuming once you get the hang of it. You can, oh, we don't want to do that, never mind. So what do we have for times? At 0, 0.1, 0.2, from there. Why isn't that getting me in that box? 2, there we go. 0.3 and 4. And you know what? I'm wasting my time here because I have the I have this stuff here, so I could have just copied and pasted it. So I'm going to do that here. Copy and paste. And there's my 5 points. I'm just going to title this properly. This is position. And I changed it to meters. All right. So there it is. That is definitely not a straight line, which maybe you expected because the puck is like speeding up as it's going down the ramp. This is not constant velocity. New unit, not constant velocity. So, all right, well, there's that. Now, what I would like to be able to do is also make a graph of velocity versus time to figure out how fast it's going. Now, this looks like whatever it is. If you went into the little curve fit option right here, what kind of curve do you think this is? It is not linear. So let's get that garbage out of there. Nope. So what do you think it is? You can go in here and look at the different things, and you could try them and just see, you know, what fits well. One of the things you can do is you can use this. You can do this power fit right here and see what exponent the machine thinks would be a good one. So if I did click on that power fit, let's see what happens. It thinks that the exponent here should be 2. That it should be some number times x, which is really time, to the second power. So if that's true, then I could just go in here. Second power, that is a quadratic fit, right? I can apply that. So second power, and then it gives me these numbers. And it just so you know, with this e minus 16, that means times 10 to the minus 16th, that is a number that is really, really, really close to 0. And 10 to the minus 18th is even closer, like 100 times closer to 0. So this B and C right here, those are really 0. So it looks like the quadratic fit is pretty good. Now, that's fine. The problem with velocity here is that to find velocity is the slope of position versus time, right? You know that from Unit 2 about constant velocity. But there we were getting nice straight position time graphs, so it was really easy to find the slope. And now we've got this curving thing, this thing's bending upwards. So how do we figure out how fast it's going? How do we find the slope? So I want to show you something here. Oh, let's see, where is it? So I made this little thing in, if you've never seen, I think you guys have all probably seen Desmos at this point. I'm going to move myself off to the side here. So here's y equals x squared. That's what I graphed here. And here's a point on it. I made a little slider so I could move that point around. And you can see as the point moves from 0, 1, 2, 3, that if we were thinking about how steep this thing is, it's getting steeper, right? Like if we imagine like a little line going through here, what would the slope of that line be? I'm not sure exactly, but as I move forward on the curve, or from left to right on the curve, it's definitely getting steeper. So here's one way that we can figure out at least a good estimate of how steep it is. So let's say we were at some point like x equals 4, and we picked a point on either side. So I picked, for the point 4, I could pick another point here at like 5, right, where x is equal to 5, and then another one on the other side of it here, where x is equal to 3. Now, if I connect those 2 points and make a line that goes through them, is a weird optical illusion. It looks like that line's kind of bending downward, but that's just an optical illusion. That's a straight line. So here, point to point here, that looks like if I pick a point on either side of 4, that would be a real good approximation, at least, for how steep this was here. If I picked a point here and this one, you can see it's kind of would be like too steep. And if I picked this point at 3 and used 4, that would be like not steep enough. If you pick a point on either side, you get a real good approximation. And if you're like, oh, well, that's fine, the slope looks right, but it doesn't go through the right point, well, you could just, you just move it down. Like there's a line that has that slope that goes through these 2 points, the green and the blue, but I just moved it down, so now it goes through the point that we care about right there. Okay, so we're going to use that idea. You don't need to do anything in Desmos. I just wanted to kind of explain why I'm going to do what I'm going to do here. So I'm going to go back to my spreadsheet. Now you really have to do this either in Excel. I'm going to come back over and say hi. That's me in the corner. You really need to do this in a spreadsheet, either in Google Sheets right here, or if you like to use Microsoft Excel, it works exactly the same way. So what I am going to do is right here, what is the velocity at time 0.1? Well, if I use the same trick that I just showed you in Desmos, what I would like to do is take the slope of this point and this point, the slope on the points on either side of time 0.1, and make that the velocity. So how do I do that? I mean, you could go through and crunch the numbers yourself, but here's a better way to do it. I'm going to type here in the formula bar. I already selected this box, that cell that I want. I'm going to say equals, and then in parentheses, I'm basically just going to set up the slope formula here. These are like my y values, right? I want rise, which is going to be this minus this. I'm getting those things to pop up just by clicking on those cells. That's my top. This minus this is like the rise, right? And over run, in parentheses, that's this minus this. Okay? And then I can go ahead and hit enter, and it puts in that number. And you can check, that'd be 0.08 minus 0, 0.2. That's the right number right there. You might be thinking to yourself, okay, that's fine, McGrath, but I could have just done that like with a calculator, and it would have been faster than all that clicking. But if you've got like 10 data points, which is probably about how many you should have, watch this. If you click on this box and then grab this little square and drag down, it figures out, the spreadsheet knows what you want to do. It knows that you want to use the points on either side. So if I click right here on this 1.8, look at what it did. It figured out to move up. It did B3 minus, it did all the right ones. Look, if I click up there, you can see what it did. Now, I didn't type any of that stuff in. I only did it for this one, right? I did it for that cell right there. But when you click and drag that box, it's telling the spreadsheet, like, try to figure out the pattern that I want you to do. And it's pretty good at figuring it out. So if you got a whole bunch of data points in here, all you need to do is set up that first one and then do the click and drag the box game. Now, a couple notes here. Why did I not drag it down to here? Well, I can't drag it down to here because there's not another point on the other side of 0.4. So you're going to have one fewer velocity data point than what you have for your positions. How about here? Well, at the very beginning, that's right when the ribbon was cut. So that is going to be 0. So I can just enter that one manually. All right, so now I can go ahead and copy that stuff. And I can go back to my graphical analysis, and I don't want to add a new data set. I want to add a new column. There we go. I'm going to add a manual column, and I'm going to call it velocity. And the units, since I am using meters, 3 meters per second. By that, and then all I have to do is click on that first box and hit paste. So now how do I look at this velocity time graph? If I click here, you can see these are the columns. You do not want to look at them both at the same time because it's like different units on this axis. So one or the other. When you're cutting and pasting stuff into your Google Doc, please don't do that. Both graphs on the same axes. So there's velocity now, and that looks pretty good. Now that does look like a straight line. So we can go to our apply curve fit. There it is. And let's see. I want to, where's my graph options? I would like to make a title here. So if I was going to cut and paste this into my Google Doc, this would be my velocity versus time graph. And I think I want the automatic scaling, but always show 0. Should be good. And all right, that's fine. And then let me go back and put my line of best fit. There's the equation. All right, so just remember, please, that we don't want to write our equations with y's and x's. We want equations to have the correct, the variables to have the correct names, and then your slope right here, which is 4, and your intercept, 0, need to have the correct units. So how do you figure out the units of slope in this case? Well, slope is rise over run. So here's meters per second. Those are the units here on rise over seconds. So meters per second over seconds, which makes sense because the slope of this is the rate that the velocity is changing. What's the velocity? Well, it starts at 0, and then it goes up to this, and then it goes up to this. That makes sense. The puck is speeding up as it slides down the ramp. So that is what I would like you to do. And if you follow the rest of the directions in the assignment that you can find in Google Classroom, that'd be super. And hope you're having a great day or evening, afternoon, whatever time it is. Maybe it's the middle of the night. Who knows? But that should set you straight. You can drop me a line and we can set up Google Meets anytime, folks, that you need me. And we can chat on screen. I think that is